Welcome to mini lesson 11.5, X velocity. In this mini lesson, we'll show you how to give your sprite the appearance of it slowing down once you stop applying the movement to the sprite. Okay, and we'll do that by adjusting the variable using some mathematics. Commonly, I'll use a multiplier whenever I want it to keep it under control while it's moving, so it doesn't go beyond the borders of the edge of the screen that it should be moving, and also it'll allow it to get that appearance of slowing down. So if we were to see it inside Scratch, and I'll click on play right here, when I start moving left, you'll notice that the sprite kind of slows down as it gets to the edge. Okay, you can barely see it, okay, but you can see it. So whenever I'm pressing the key, it just kind of comes to a gradual stop. That's just for a visual appear during the game. Gives it a little feel of physics whenever the character's moving around. And we do this by having a variable, and this one we call it X velocity, and we're taking the variable X velocity and setting it to itself, and we're multiplying it by 0.85. By using a multiplier right here, it basically means we're always going to keep this variable at 85% of its value. Okay, so that way we keep it under control no matter what the user is pressing. And the screen's so limited that we can keep it under control, so there wouldn't be a situation where it just keeps going and going and going and it would eventually get out of control. Since we have limited space, it would never get out of control while we multiply it by 0.85. Okay, right here we change the X value by the variable right here. That's what causes it to move left and right. And right here, you've seen this before when we were doing the maze game, pressing the right arrow and the left arrow and checking to see if the colors are touching for the sensor will cause it to start, or excuse me, to stop and not be able to go through the walls. You can see that when I try to go through the walls right here, it keeps kind of bouncing back right there. So that's what's happening right here. Okay, and one thing a little bit different is, okay, notice I said it was kind of bouncing back. What we're doing is once that collision happens, we're actually setting the X velocity to a value that's opposite of its current value. So right here, if it's moving right, that means X velocity is a positive value. And let's just go ahead and show you. So it's moving a positive value, but once it hits that wall, I'm setting it to a negative value, and that negative value will cause it to start moving backwards. And it moves backwards because we set it to a negative value. The code stops right here. We know this isn't true because I've been pressing the right arrow. I come back and we take that -1 times, -1 times 0.85, so it's basically -0.85. Then we change the X velocity by a value. We see if right arrow is still pressing. That's true. If this is still true, then we set the X velocity back to -1 and go back through the code and do it again and again and again. Okay, and we'll keep doing that over and over again until it's not touching anymore. Now, once the sprite is off of the blue touching the black and the right arrow is still pressed, we'll change the X velocity by 0.5. And that'll keep increasing as we press it. However, this multiplier right here will keep it under control so it never gets too large that the sprite moves off the screen and just gets out of control. Okay, and the same holds true down here for the left arrow. Okay, let's go back to our presentation. Okay, so here's some terms you need to know. We don't really get into the calculations of this, but I put it out there because it's important for you to know this terminology, especially if you want to advance your skills in programming or science or physics, which physics is science. Okay, so velocity, that's going to be speed of an object plus its direction, and the formula for speed is distance divided by time. We don't really sit down and calculate that, the speed or the velocity in these lessons, but it's good to know that just in case you got to get very specific. Then acceleration and deceleration, those are a little bit more difficult to actually program. However, they're very easy to simulate with some simple mathematics. And an acceleration would just be the increase of the object's speed, and the deceleration would be the decrease of the object's speed. Okay, so pause the video and read through those examples, and it'll make sense when you actually start working on it. And again, like I said, we don't really worry about the programming of these aspects, but I think you should know the terms. And we're looking at Newton's second law right here. So when one or more forces have been applied to an object to get it to accelerate, the total force acting upon an object causes it to accelerate. Okay, so what we're really saying is those forces will be applied to an object, they're greater than its current force, whichever direction it is, they'll cause it to accelerate, which means increase its speed. Okay, and that's generally Newton's second law. It gets a little bit more detailed if you start looking into the actual second law, but it's good to know that in the back of your mind while we do these things. Now, just so you know, if we wanted to, now we'll address this later, there really is no force being applied here. Okay, there's no force. We're changing the x-axis position with math right here. And this is all abstraction. This isn't real. I mean, I can't reach out and physically make this thing move with my finger, okay? It's just a computer image. So keep those ideas in mind while you're programming, that, yeah, we're trying to program physics on something that doesn't really exist in matter, or it doesn't have real mass. So, you know, that makes it very difficult to work with sometimes, and you got to train your mind to think a little bit differently. The multiplier, again, pause the video so you can go through and read this material. I'll break it down quickly here for you. So the multiplier is just going to be the number that you multiply by. Okay, that's just a general mathematics term, and in our case, we're just using the multiplier to keep the values under control. So the velocity on the x-axis of the sprite doesn't allow it to go through the walls of the screen. Just give you an example. I'm going to get rid of this. I'll put this right up here, and let's run the program. So if I try to run it, boom, you can see that it almost goes through it, doesn't it? Okay, it's almost going through it, almost. However, I can program it so it will go through it. Let's change this to 2. Okay, let's start it, and almost, there we go, we're starting to get there. Finally, I got it. Okay, see what happened there? That sprite just went all the way through the wall because I didn't have a way to keep the x velocity under control when it was moving. This multiplier on this piece of code right here gives me that ability to keep it under control. Are there other ways to keep it under control so it doesn't go through? Absolutely. However, this is the way I chose to manipulate the sprite. Okay, so let's go to the next one, and that's it for this mini lesson. You won't program the stage. I can't remember. Yeah. Oh well, the stage again. I host the start method here on the stage, so make sure you get that on there. And then the majority of the code will go on the sensor sprite right here. Okay, got a little tongue-tied there. Saying sensor and sprite in the same word, it's a little bit difficult for me tonight. So thanks a lot for watching, and we'll see you in the next video.